Okay, welcome back. Well, today we're going to solve a very complex question, which is about the reasons are very complex is because of very lengthy. Before I do that, can you please make sure you subscribe channel so you don't miss the updates, and also give us thumbs up so let this channel to continue grow. Thank you for that. Okay, today we talk about question 19, QCAA External Assessment 2020, paper 2. So this, the object is swing at end of a circular motion, so which is radius is 0.5 meters. Then in the circular path, it's constant angular velocity. So angular velocity, talk about angular velocity shortly. So the complete each revolution is take about 0.24 seconds. So object to project at a height of 0.3 above the ground and the vertical plane, just to pass over a narrow pole. So this is a narrow pole. With the height is 2.505 meters, and the base is 14 meters horizontally from the object was projected. So this is the diagram show you the flat top of vehicle. So there's a vehicle flat top with the length is 0.6 meters, height is 0.4. Initially is rest. At against the pole, so at the bottom of the pole, show on the ground, show the diagram, and the instant when the object's projected, the vehicle moves horizontally in a direction away from the pole. In the same vehicle plane with accelerations a meters per second. So the object strike the middle of the top of the vehicle. So that's the object strike in the middle, point A. Assuming a resistance are negligible, so the vehicle, so we use a vector calculus to model the motion and projectile in order to determine the value for acceleration A. All right, so let's do a few things. In order to establish the model of motion, we need to find a few things. First, we need to find the angular velocity in circular motion. So I got two formulas for you. One is the angular velocity is 2 pi divided by time. So that's the period. So that's a capital T. And the second one is angular velocity can be used the magnitude velocity times by the radius. So therefore, the magnitude velocity will be angular velocity times by the radius. So I'm going to use those two formulas established. First, I'm going to let the angle, because when you establish the projectile motion, you must have an angle. So it's very important. So I'm going to say let the angle is theta from the ground. So, but we need to find out what is the velocity first. So therefore, the magnitude, so we do the angular velocity 2 pi divided by 2, 0.24. So that give you answer is 26.18 radian per second. So that's the angular velocity for circular motion. When the velocity, magnitude velocity is, we know, is the angular velocity times by radius. So it'll be 13.09 meters per second. So now we're going to establish the projectile motion. So let's do the velocity function in relation. So let's do the I component first, which is x. So the I component, which is x component, is 13, which is the length of the vector, 13.09 times by the cosine theta. So we don't know what a theta is. So that's the x component. The j component, which is y component, is the, first we need to find that's the y component, but you need to take away we know the vertical velocity is opposite, so which is a negative 9.8 j. When you put a v, become integrated negative 0.98 t j. So therefore we need to subtract. So that's the net of the y component, which is the projectile y component. So therefore my total vector velocity function, which is two components. We've got an I component is 13.09 cosine theta. The y component is a bit longer, so we need to consider that. So now we're going to do the projectile motion for the position vector. So position vector is, so we're going to integrate it, the x component and the y component. Now, why I need to put a 0.3? Because that's the initial height, which is 0.3. So I'm going to separate it into two parametric function with the relation in relation to t. Equation 1 is x component, equation 2 is y component. So why we do that, we need to find the angle, because in order to find the entire projectile motion, we must decide what a theta is. So first thing is I'm going to eliminate it, because you've got two variables. One is a t, one is a theta. So I'm going to use 1 change to 3. So that's equation 3. T is x divided by 13.09 cosine theta. Then we substitute 3 into 2 to eliminate the time. So you can see I got a y component is a theta only. So that's the answer for, so sine divided by cosine is 10. Then 4.9 divided by square root, 13.09 square, which is that. So that's to become cosine square on the bottom. Now, because the 14, which is the x, and 2.05 is the it's on the graph, on the path. So we're going to substitute, so which is on the path. So we're going to replace y with 2.05, then x, I'm going to use 14, so that I can find an angle. So I'm going to use a graphics digital calculator to find a theta is 0.6444 radian. Right, now we're going to substitute back to the y component, so you need a height. So we substitute, so we get that, a quadratic. So that's y component. So when the object hits the vehicle, so that means y is 0.4. So we can decide what the x is. So I'm going to substitute 0.4 to y, so we can work out what is the horizontal distance. So the horizontal distance when the object hit the vehicle is two of them. One is 0.134. Obviously, it's not correct because the x must be, when you hit the the vehicle must be more than 14. So therefore, we need to choose the second one. So now we're going to substitute into the equation 3 to work out the time. So what time they hit the object. So I'm going to substitute into the 3. So using graphics calculator to find a 1.592 seconds. So the full motion of the vehicle, before we finish, because we need to work out the acceleration of the vehicle. So we're going to work out a motion for the vehicle. So first, we know the motion, the acceleration function is magnitude of A times by I, which is only horizontal, no vertical. So we're going to VT integrate that. So be acceleration Ti plus C. So when the vehicle starting at a rest, so which is 0, so C must be 0. So therefore, my velocity for the vehicle is AT. Then we integrate it. When integrated, you need to find the X component is half AT squared plus C. But when you hit the middle of the cart, because you hit in the center, so the X horizontally is 14.3 because the total length of the vehicle is 0.6. So therefore, C is 14.3. So that's horizontal. All right, now we put a time into the X component, and also we know the distance when the object hit the cart is 60.66. So we substitute to the equation. So then we can work out A is using GDC to find it was 1.8 meters per square second. So that's a very long solution. So hope you enjoyed it. So please don't forget to give us the thumbs up and subscribe channel so we can continue letting this channel to grow. Thank you again. I'll see you next time. Bye.